To determine if the trough size is acceptable per the National Electrical Code, or NEC, we must calculate the cross-sectional area of the conductors and compare it to the allowable fill percentage of the trough. According to NEC Table 312.6, A. The cross-sectional area of the conductors in a raceway, including all circuits, should not exceed 40% of the interior cross-sectional area of the raceway. In this scenario, the trough has dimensions of 12 inches by 12 inches, resulting in a cross-sectional area of 144 square inches. Therefore, the maximum allowable conductor cross-sectional area is 144 square inches multiplied by 0.4, which equals 57.6 square inches. We need to determine if the existing and new conductors meet the requirement of 57.6 square inches to be acceptable. First, let's calculate the total cross-sectional area of the existing conductors. There are 16 3/0 conductors. Based on the NEC tables, each 3/0 conductor has a cross-sectional area of 0.2266 square inches. Multiply 16 by 0.2266 square inches, which equals 3,6,256 square inches. Additionally, there are 8 500 mcm conductors. Each 500 mcm conductor has a cross-sectional area of 0.8067 square inches. Multiply 8 by 0.8067 square inches, resulting in 6,4536 square inches. The total cross-sectional area of the existing conductors is the sum of 3,6,256 square inches and 6,4536 square inches, which equals 10,792 square inches. Next, calculate the total cross-sectional area of the new conductors. There are 4 number 4 American wire gauge, or AUG, conductors. Each number 4 AWG conductor has a cross-sectional area of 0.511 square inches. Multiply 4 by 0.511 square inches, which equals 0.2044 square inches. There are also 4 350 mcm conductors. Each 350 mcm conductor has a cross-sectional area of 0.5556 square inches. Multiply 4 by 0.5556 square inches, which equals 2.2224 square inches. The total cross-sectional area of the new conductors is the sum of 0.2044 square inches and 2.2224 square inches, which equals 2.4268 square inches. Finally, the total cross-sectional area of all conductors, existing and new, is the sum of 10.792 square inches and 2.4268 square inches, which equals 12.506 square inches. Since 12.506 square inches is less than the maximum allowable conductor cross-sectional area of 57.6 square inches, the trough size is acceptable according to NEC Table 312.6. Now let's assess the feeder capacity. The existing feeder capacity consists of 2 sets of 500 mcm per phase. Typically, 500 mcm conductors are rated for approximately 380 amps per phase, so 2 sets would provide a capacity of 760 amps per phase. The additional load includes an 80 amp disconnect and a 300 amp disconnect. Therefore, the total additional load is 80 amps plus 300 amps, which equals 380 amps. Given that the existing feeder capacity is 760 amps per phase, it is sufficient to handle the additional load of 380 amps. As suggestions, firstly, ensure that all conductors are appropriately sized and terminated in accordance with NEC requirements. Secondly, verify the voltage drop on the new circuits to ensure it remains within acceptable limits to maintain efficient and safe operation. Thirdly, consider the impact of the new load on existing overcurrent protection devices and adjust or upgrade these devices as necessary to ensure adequate protection against overloads and short circuits.